Today lesson we learn compacting and finishing, and we have 4 learning objectives to explain the principle and procedure for compacting and finish grading, and we determine the amount of water required and the rate of water application when compacting, because normally the borrowed material uh, water content in that borrowed material may not be meet the optimum water content specified for per plan and specification by designer. And then we classify the equipment for compacting and grading, and then estimate production of rollers used for compaction and grader used for grading and finishing. In terms of the principle of compaction basically a process of increase the soil density by mechanically forcing the air get out of the soil, so that on the solid part of the soil closer together, so increase the desired densities. And we should not confuse between compaction and consolidation, and that you learn in Geotech 2. Consolidation also the process of increasing the soil density, but is about to expel or to get the water out of a cohesive soil for clay, etc. Compaction expel the air, consolidation expel the water out of the clay cohesive soil. And with that consolidation, it can take months or years to complete, while compaction can be accomplished in a matter of hours or a days. And that we will learn that today is compaction, not consolidation. That if you're interested, that in Geotech 2. And of course, to determine the what is the compaction level needed, the test is the Proctor test and modified Proctor test to determine the optimum water content, and that you also learn in Geotech 2. And I just go a quick overview what is that about in here. So this graph familiar with you for to determine the desired density, and also the relationship between the water content and the desired dry density. We do the compaction several times with different level of content. For example, for standard Proctor, we drop with the water content and measure the desired dry density here. And then of course other water content, and we have that curve for a certain soil. And from that curve we can see the optimum water content is about 20%, with the maximum desired dry density, maximum dry density in this case about 105 pound per cubic feet. So that is the optimum water content that we determine. Then the other method that called modified Proctor test, basically the compactive effort 4 times as much as the standard Proctor, and you learn that with different procedure, how many blow, etc. in Geotech 2. In the textbook here, you in chapter 5, you also have that table to describe the difference between the modified Proctor test and standard Proctor test. And as you can see, it's not surprised, because the compactive effort in the modified Proctor test is 4 times as great as the standard Proctor test. So we need the less water content and achieve the higher dry density. For example, here it only need 15% water content, and we can achieve with that same soil about 117 pound per cubic feet. So that is the relationship between the dry density and water content to determine the optimum water content to achieve the maximum dry density, and with the test. And of course, the next figure will show you, of course, different type of material have different behavior, different curve for water content or moisture content with the dry density, as you can see there. And with that, we go back to here now. So in construction, how can we determine and make sure that we meet the requirement of the engineer specify for compaction, and that go back to the node that we have here, and you can see that is they need to specify, for example, specify somewhere in compaction, somewhere in terms of density requirement 90% of standard Proctor test. For example, in the graph that you show here, that one, with the standard Proctor test, we can achieve the maximum density, dry density 105. If we specify 90%, so you have 105 times 90, so it's about 99.8 pound per cubic feet. Okay, and similarly, if we have a higher standard, like do the runway in the airport, we may specify up to 100% of modified standard Proctor test. So it will require more compactive effort, etc. So that is the way to specify. Now, when you specify that, how can we make sure now we do on the field? How can we make sure that we achieve what already specified in plans and specification by engineer? And that come up with the field compaction tests. There are a few methods to do. The first is the liquid and sand test. Those consider the traditional method. So basically, you go on the field to dig out one hole and then get that sample in, evaporate the water, measure the weight of the dried part, so solid part, and then the volume. For the volume, we measure whatever the hole we dig, and if we use liquid, for example, the gasoline, liquid, okay, lubricant, oil, etc., then we, if it cohesive soil that have very difficult to permit surroundings, you can put the lubricant directly in that hole to measure the volume. So go to in lab, we measure the weight after the water out, so it dry weight divided by the volume. With the liquid, we can determine the dry density compared with the whatever specification, 90% of the standard Proctor test or 95% of modified Proctor test, etc. And that is one method. The other traditional method is sand test. So basically, instead of the lubricant, we put sand on the hole that we dig, and then we measure that volume by the sand, whatever the sand occupy that volume. And that it takes time for those traditional method. The other method, we have a nuclear density test. So basically measure radioactivity from the calibrated shot to the compacted material, so that it can be determined both density, dry density, and the moisture content, the water content, that is nuclear density test. So it will be faster, more efficient. And of course, the other method that I don't list here, that non-nuclear density test. So basically it's similar, but it's safer, lighter, and also quicker. But now with the equipment like Caterpillar, some other compaction equipment, they have something like equipment mounted compaction measurement and control system. So in real time, they measure what is the density achieved, what is the water content achieved when we compaction, so that we can adjust the number of passes, etc. That is the equipment mounted compaction measurement and control system. So we can adjust on site and make sure it everything in order, instead of the traditional method we compact and go back to that to see whether it already meet the specification, and it may be too late for that, and sometimes it needs rework. So go back to here. So with that, what are the equipment we use for compactions? There are multiple compaction, and this is I extract from the book, and you can see that smooth steel wheel roller I can use for compaction, and then 12 propel vibrating roller. So in terms of the compaction, there is four ways to apply energy so that we can expel the air out of the soil. It can be by impact, so shaft flow, can be by pressure, so you have the weight of that equipment here, so pressure on the compaction material, or you can use vibration, so some of the equipment here can be vibrated, or it can be kneading, so it rearrange, manipulate the material so that reduce the air out of the soil. So those are the four ways that you can impact energy apply energy for compaction. And different equipment here, as you can see, for different type of material cannot be universal applied for all the material. So let's see this also from the book here. For steel wheel, pneumatic, here that you can have different equipment. This is pneumatic, steel wheel, you have a vibratory, tamping foot, and grid. The grid is here. Okay, so you have that equipment. If you apply for rock, so it's better use steel wheel or vibratory or tamping foot or grid. So the rock, as you can see, except the pneumatic, everything can be used. All other equipment can be used for compaction the rock. And it go, as you can see, from rock to very heavy clay. So from gravel to clay. So gravel, clean or silty, as you can see, it's similar to the rock. So it almost all equipment can be used. Pneumatic is acceptable, but it's not recommended. Gravel, clay is, then it vibration is not applicable. Grit, it should not be recommended. So for the gravel with some clay cohesive, steel wheel or tamping foot should be used. And then for sand, clean or silty, Florida, vibratory is the best to compact with the sand. If some clay is sealed, then we have tamping foot can use, and of course other is acceptable as the pneumatic, vibratory, and grit. How about the clay, mossy clay with some sandy or silty? Then when it's come to clay, cohesive soil, as you can see, pneumatic increase the application, and then tamping foot also application in there. Finally, clay, heavy clay, and as you can see, pneumatic, and then tapping foot. So bottom line, rock is okay for most of the equipment, as you can see there, except the pneumatic. For clay is pneumatic or tamping foot, and tamping foot can be applied all other type of material except this clean or silty sand. And you can see that. So different equipment can use for different material, cannot be universal applied for all time of material for the compaction.